Okay, today we're going to start talking about lesson 822, which is complex roots. Remember, complex is just another way to say that we're going to have imaginary parts. So complex numbers are always going to be written in a plus bi form. And so everything that we solve today and we find roots for are going to be in this form. Now remember, roots is another name to say solutions, zeros, and we usually think of them as x-intercepts, but in this case with complex, it's not actually going to be x-intercepts, but all of these things mean exactly the same. So let's look at 8-79a to start with. It says find the roots of y equals x plus 5 squared plus 9. And really quickly, I'm just going to sketch to the side. This is in graphing form or vertex form, so I know that the vertex is -5, +9. So I'm just sketching. It has a positive orientation, so I know it's going to open upwards. And of course, it's squared, so it's a parabola. So we can see that this graph is never going to cross the x-axis. So it doesn't have any x-intercepts. But remember, based on what we've been learning this week, it doesn't mean that it doesn't have any solutions at all. It just means they're not going to be real solutions. Okay? So if the graph never crosses the x-axis, it will only have imaginary or complex roots or solutions. Okay? In order to find the roots, just like we would find solutions or zeros or x-intercepts, we would put a 0 for y and we would be solving for x. Okay? And I know some of you would want to multiply this out with a generic rectangle and simplify and either try and factor or use the quadratic formula, but I'm going to undo because undoing is a little bit faster. So I'm going to subtract the 9 on both sides. Okay. I'm going to take the square root of both sides, and of course I'm going to remember when I take the square root of something squared, then I have to use plus or minus over here. Okay. So on the right side, it's just going to be x plus 5, and on the left side, we now know that the square root of a negative number does exist. It's just imaginary. We know the square root of 9 is 3, so I have plus or minus 3, and the I because there's a square root of a negative. Okay. I'm not quite done yet. I don't have x by itself. This is x plus 5, so to get x by itself, I'm going to subtract 5 on both sides. And this represents two solutions, or two roots. Okay? Usually we write it together. Remember, it means -5 plus 3i is one of the roots, and -5 minus 3i is the other root. Again, we always want to write it with the real portion first and the imaginary second. That's the standard form of a complex number, a plus bi. Okay? Next, I'm going to shift us over a little bit. I'm going to come back to that other board in a minute. And I'm just going to move it. Same question, different equation. 8-79, part B. Now when I look at this, I cannot picture in my head what this is going to look like. So if I throw that into the graphing calculator, hopefully you can see that, or you can throw it into yours, it does not cross the x-axis at all. So again, it's not going to have real roots, but it will have complex roots. So I put in a 0 for y, and I have to solve. Okay? If it never crosses the x-axis, it is not going to be factorable. And again, that doesn't mean, oh boy, worst split of a word ever. Okay, so if it doesn't cross the x-axis, it's not going to be factorable. Don't even try to factor it. We have to use the quadratic formula. Okay, so as a reminder, quadratic formula, opposite of b, plus or minus the square root of b squared minus 4ac all over 2 times a. That's important. You need to know that. Make sure you get that in your notes and you can find it easily. Okay, and of course, when we use the quadratic formula, the a value is whatever number is in front of the x squared. The b value is whatever's in front of the x. And the c value is the constant term or the thing that's left over. Okay, and of course the signs stay with the numbers. So quadratic formula, -b, so the opposite, plus or minus the square root of b squared. Now remember, anytime I square a number, it's always positive. So even though that's negative 4, when I square negative 4, it will be 16. Okay? Minus 4 times a times c, all over 2 times a. So 4 plus or minus square root of 16 minus 36 all over 2. When I subtract, I get negative 20. Okay, and we no longer stop and say no real solution. We say, oh, well, that means it's a complex solution or an imaginary solution. And we don't know the square root of 20. So I'm going to write it as I root 20. And remember, I want it in this a plus bi form, so I need to split it up. Okay, I'm really distributing. The 2 on the bottom represents 1/2, so I'm really distributing the 1/2. So 4 divided by 2 is 2, plus or minus. And I'm going to put square root of 20 over 2i. Okay, if you want to simplify that radical, that's great. If not, this is completely fine. Okay, now question 8-80 asks us to take a look at our roots. Okay, so we have 2 different problems. Take a look at our roots and see if we notice any patterns. So here I have 2 roots, here I have 2 roots. Okay, hopefully you notice that there are 2 roots in each one. They're both imaginary, and hopefully you notice they're the exact same thing except for the imaginary part has opposite signs. Same thing over here. If I write this out as 2 things, it's 2 plus root 20 over 2i and 2 minus root 20 over 2i. Okay, so they're exactly the same thing. They're just different signs in the middle. Okay, so those are going to be some important patterns that we pay attention to later on in the chapter. The last thing I want to talk to you about today, pause for a minute, put this one back, is called the discriminant. And if you had Mrs. Sarney for Algebra 1, you already really focused on this with her. If you had other teachers for Algebra 1, I'm sure that they also talked about it. You may or may not remember. Okay, so when we're solving these, I'm going to pull these back for a second. These just said solve or find the roots. So we went all the way until we had solutions. But sometimes we're going to ask you, when looking at an equation, are the roots real or non-real? Okay, and this one was really easy for us to graph quickly, sketch a graph quickly, and see that because it does not cross the x-axis, we know that the roots would be imaginary. So if that was the only question here, we would know immediately by sketching the graph that those have imaginary roots. Okay, this one, if we didn't have access to a graphing calculator, it wouldn't be so easy. But the reason that this one was imaginary was because we had a negative inside the square root. So the discriminant is actually just this stuff inside the square root of the quadratic formula. Okay, b squared minus 4ac. And we can use the discriminant to decide, do these have real or complex roots? And again, I can't look at this and just know off the top of my head what this graph looks like, or this one. So instead of doing the whole quadratic equation, because the question's not asking me to find what the roots are, it's just saying, are they real or complex? So all I have to do is b squared, okay, so 5 squared, minus 4 times 3 times 4. Okay, so I get 25 minus 48. Okay, and I don't actually even care what this ends up being. All I care is that 25 minus 48 is going to be a negative number. Remember, the discriminant came from inside the square root. So if I have a negative inside the square root, that's going to tell me I have complex solutions. Okay, let's try this one. Just using the discriminant, b squared minus 4 times a times c. Now this time I have a negative 4 times 3 times negative 4. Negative times a negative is positive. So this is going to be 25 plus 48. Again, I don't even care what that actually is. All I know is a positive plus a positive is a positive. And again, thinking about the discriminant, if there's a positive inside the square root, that is going to give me technically 2 real solutions. Okay, whoops. This one is going to have 2 complex solutions. Complex solutions or imaginary solutions always, always, always come in pairs.